We retired the space shuttle this past year after 30 years of excellent service to our nation, and its time had come. It had been a fantastic program. It had done amazing things. But now NASA's ready to really take the next step, which is a more continued presence in outer space beyond low Earth orbit. Our ultimate goal is to get humans to Mars. When we started this project, we thought we were really clever thinkers. We had some technology we wanted to explore that involved multiple wheels and the ability to turn in any direction. They thought, well, what if we build a cabin and have the crew go out for multiple days? And that's really where this small pressurized rover concept has really evolved into the space exploration vehicle.
So the SUV will hold 2 astronauts. They basically live in this module, in this rover. It's your own personal SUV in space. You always want it to be as light as possible. You also want it to be strong enough that it's got your safety factors, that nobody's going to get hurt. You're going at several thousand miles per hour just to escape the Earth's atmosphere. So you've got to be able to handle all these vibrations and all these different things just to be able to get out into space, and the vehicle can't be damaged. There's probably around 60 to 80 parts on this particular rover. It's all done by additive manufacturing for a lot of different reasons. You know, sometimes traditional manufacturing methods don't really work for some parts that you want to build, where you can do it with additive manufacturing, and it's really simple. It really takes no effort for what would otherwise be a very complex process. Whether it be ducting that's got flame retardant characteristics and properties to it to help keep people safe, or different fixtures and different parts, there's absolutely a place for additive manufacturing. There's a lot of things that you don't see that really get to go on is the design verification and the functionality checks of parts before we send them to be manufactured. If the final product is not going to be an additive manufacturing plastic part, we will do it in a rapid prototype fashion where you'll get it back in maybe an hour, a day. What that allows us to do is be able to check our design and make sure that everything's going to work the way we think it is. Sometimes vendor components are a little bit different than what you anticipated, what the drawings say. So you're able to functionally build up this assembly and check it to say, hey, this is what we want, or hey, we need to make some tweaks. So by doing additive manufacturing, rapid prototyping, it allows you to keep your costs down. Everybody's got a budget to deal with, and we're no different. Being able to make a difference and leave my mark is really what inspires me. You know, that's what gives me the drive to do what I do.